Hello everybody. In this video we are going to study about flip-flop conversions. Okay, so the basic thing over here is that we want to design a particular flip-flop, okay, with the help of one flip-flop and next state decoder. Okay, what is the meaning of that? For example, let's say I want X flip-flop, so X flip-flop will have its own present state and also have its future state, is next state. Okay, also to get this future state I have to give two inputs or one input. So let me take two inputs over here. Okay, the inputs are A and B. So if I give inputs A and B to this flip-flop at present state, it will give me future state. Okay, so now what I'm going to do in flip-flop conversion, I have Y flip-flop with me. I'm having Y flip-flop with me. With Y flip-flop, okay, I want to design X flip-flop. Okay, so for that I should know the present state and input A and B. Okay, and I should give in such a way that this Y flip-flop will give me output of Qn plus 1, okay, of this X flip-flop. It will not give its own Qn plus 1. It will not give it is also having Qn plus 1 and Qn, and it is also having its inputs, let's say A and B. Okay, so I want to design X flip-flop in terms of Y flip-flop. Okay, so I have Y flip-flop with me, but I want the output this one, Qn plus 1. So what I will do, I will take Y flip-flop plus a combinational circuit, I will take. Okay, this two together, Y flip-flop combinational circuit will give me Qn plus 1. Okay, and what is the input I will be giving? I will be giving the input A and B, or a single input with Q1. Okay, with Q1 means by understanding what is a present state. Depending on the present state, I will give the input in such a way, okay, that the combinational circuit will modify and give the input to Y, okay, and Y will be forced to give me Qn plus 1 of X flip-flop, not its Qn plus 1. Okay, so with example it will be more clear. Let us see that. See, I have taken a general, this is the general structure, this is the general design, okay, where I have let's say this is the Y flip-flop which I'm just describing. This is the Y flip-flop and I want to design X flip-flop. Okay, so what I'm doing, I'm taking a next state decoder. What is this next state decoder? It is a combinational circuit which I have to design. Okay, once I design this, okay, this combinational circuit will take the input, that is AB. Okay, it may be a single input also depending upon the circuit you want to design. So it will take the input, okay, and the present state of the flip-flop, okay, and it will combine such a way the inputs that it will give the input for the Y flip, this Y flip-flop, okay, which I'm having. It will give the inputs to Y flip-flop, but I will get the next state which is the output of the flip-flop which I want. Okay, for example, I have taken a D flip-flop design using SR flip-flop. Okay, that is called realization of D flip-flop using SR flip-flop. So see, the same thing I copied over here, next state decoder. Here AB is input is there, but here I want to design D flip-flop, so I taken a single input, that is D. Okay, and I'm designing with SR flip-flop. So you can see C and D is nothing but SR. Okay, so this is Y flip-flop. So I'm using SR flip-flop and next state decoder to design to get the output of D flip-flop. So this next state decoder I have to design. Further, what I have to do? See, I have taken present state and next state table of D flip-flop. So present state I know Q1, okay, and I know what input I have to give as a D to get my future state. Okay, so this already I have explained in earlier videos of flip-flop. You can see in those videos to understand what is present state, next state, and what is excitation table. I'm just going a bit fast over here. So see, Q1 I have taken, Q1 is present state, maybe 0, maybe 1. So if it is 0, I may give input as 0. If it is 0, I may give input as 1. Similarly, if it is 1, I may give input as 0. If it is 1, I may give input as 1. So if I give this inputs, and we know in D flip-flop whatever input is given to D, the same thing will come as the output. So I got the same thing. So is the present state, this is the next state. Okay, so this is the present state next state table of D flip-flop. Okay, now I want to design this D flip-flop in terms of SR flip-flop. So I have to see the excitation table of SR flip-flop. What is excitation table? You can refer my earlier videos regarding that. Okay, so here I have taken SR flip-flop excitation table and I joined that with present state next state of D flip-flop. Okay, so Q1 D, Qn plus 1, and the excitation inputs of S and R. Okay, why I have taken this? Because you see, as I have told you, this I am designing. Okay, so I will give the present state and D in such a way that I will get the next state of D, next state, okay, that is Q1 plus state of D from SR flip flop. SR flip flop will not give its own next state, it will give the next state of D flip flop. Okay, that was just trying to explain over here and over here also. Okay, so see what I'm going to do. Present state is Qn, D is 0, future will be or next will be 0. Okay, so in this way I have copied my present state next state table over here in excitation table. Now I want to give SR flip flop inputs. Okay, because you can see in the diagram next state decoder is giving input to S and R, C and D over here, that means S and R over here. Okay, so I have to give the input to S and R. So see, present state is 0, future is 0. Okay, means next state is 0. So S should be 0, R should be don't care. Why? Because 0 0 or 0 1, two conditions are available over here. Okay, so R may be 0, may be 1, but S should be compulsorily 0. That's why it is don't care. Okay, accordingly I have taken 0 to 1, so 1 0, 1 to 0 0 1, 1 to 1 don't care 0. Why it is like this? Please refer my earlier videos for excitation table of SR flip flop. Okay, so SR flip flop, here I have taken RS flip flop, so both are same thing, S and R or RS is same thing. Okay, don't confuse over here, RS flip flop I have written, but I have taken S and R. Okay, the same thing only. Now, so I get the excitation table. Now once I get this, I will be designing the K maps. Okay, now what I have done is that I have taken K map for S and R. S and R. Okay, so S is depending upon what? Present state and D. Similarly, R is also depending on present state and D. This Qn plus 1 we are expecting. Okay, but S is getting input from where? From the present state and D. Okay, so I have taken Q1 and D for S. Similarly, for R also I have taken Q1 and D. And by this time you know how to get equation for the K map. So I have designed the two variable K map over here, and from that for S variable I am getting D, for R I am getting D complement. Okay, so this is what this next state decoder equation. So you see what I am doing. For S I am taking D, and for R I am taking D complement to this inverter. So this is what this is next state decoder. Okay, and this is the flip flop we used. Now this total circuit, if I say total circuit, this is my SR flip flop and this is my combination circuit. So the combination circuit plus SR flip flop joined together, okay, give working as an D flip flop. Okay, so D flip flop using SR flip flop. So you can see this circuit and this one both are same, and next state decoder we have designed, this is nothing but this part. So here at this circuit we can say that we have designed D flip flop using SR flip flop. Okay, one more example I have taken over here. There is relation of JK flip flop using SR flip flop. So here I have omitted this PS and NS table, because by this time you know what is present state and next state table. So I have joined to directly from the excitation table I have started working. So Q1 plus 1 present state next state, I have taken JK and S and R. Okay, so excitation table you know how to design, so I have designed that. Okay, and depending on that I got the S and R values, and S is depending on one Q1 JK. Okay, and R is also depending on Q1 and JK. So accordingly I have taken the K map, and from that I got the equation S equals to J Q1 complement and R equals to K Q1. Okay, so accordingly I have designed this circuit. So this part is nothing but next state decoder. So you can see over here J and K. So this resembles the first diagram which I have shown in general form. J may be A, K may be B. Okay, so here this is two input. Here in terms of this D flip flop is a single input, but here is two input, as I have told you in the beginning. Okay, this block is next state decoder which is having two AND gates, and I am getting feedback from this path, from the output of SR flip flop. Okay, so here I am designing JK flip flop using SR flip flop and next state decoder. Okay, so this total circuit is behaving as JK flip flop, and if you remember, it is nothing but similar to JK flip flop circuit. Okay, so this is how we are designing one flip flop using another flip flop. Okay, I hope the concept is clear to everybody. Thank you for watching the video.